What are spectra? So spectra are a little complicated, but basically a spectra is a description of the kinds and amount of light that something's giving off. And I'm going to explain that better in a little bit, but first I need to say a little bit more about color. So, first off, with respect to, Roy G. Biv, you may have noticed that some things weren't in there, like white, something you might expect. Well, that's because white is not actually a color. White is a bunch of colors mixed together. So mixed together that our eyes can't distinguish between them. And so our brain interprets that mixture of many different colors as white. Black is also not a color. Black is how our brain interprets the absence of color. And brown is also not a color. It's another way that our brain interprets a mixture of many different colors. So, in that sense, we need to think about what does it mean for something to have color. So, let's say we have a blue ball. What does it mean that the ball is blue? Well, here's what it means. If we shine some white light, like from a ceiling lamp, or the light from the sun is pretty close to being white, that's actually a bunch of different colors all mixed together is white light. So maybe we can draw white light as being something like that. But then when that white light hits the ball, most of it is absorbed by the ball, but not all of it. Out of the light that's not absorbed, most of the light that gets reflected is blue. And so it's the blue light that can then go into our eyes. And since when we look at the object we see blue light, the object looks blue to us. So, that's what it means for something to be blue. That's what color means in the context of a property of an object. Now, a spectra, as I said earlier, is a description of the amount and types of light that something is giving off. And one of the easiest ways to represent it, I think, is as a graph. So let's imagine what a spectra for fire would look like. You look at fire and you think, okay, it looks orange, it looks yellow, it looks red. I'm thinking it gives off those colors. But that's not quite accurate, because you gotta think, if I were to bring this blue ball up to the fire and look at it in the fire's light, I would still be able to tell that it's blue, even though the fire's red. So that means that the fire must be giving off some blue light. It's just only a little bit of blue light. Enough that our brain averages it out, makes it look orange or red. But there is some blue light in there, because I can see that my blue ball is blue in the firelight. So with that in mind, a spectra for fire might look something like this. We have a graph. The y-axis is amount of light. And the x-axis is wavelength, or color. So we could say, focusing in just on visible light for simplicity, here's our x-axis, Roy G. Biv. And so we're looking at this fire and we're thinking, yeah, it's got a good amount of red and orange, a pretty solid amount of yellow too. Oh, sorry, messed that up a little bit. Red and orange and a pretty solid amount of yellow too, but not so much green and a even smaller amount of blue and violet. Okay. So, you could also, at this point you might want to connect your dots, something like that. So that's something like what the spectra for a fire would look like. The spectra for a white ceiling lamp, on the other hand, might look something like this. Be a lot more even, a lot more evenly distributed among the different colors. So, however, spectra like this are not what I'm going to be talking about for the rest of this week's lecture, which is a little weird, but it's the way it is, and it will hopefully make sense to you soon. So, I'm going to be talking about spectra that look something more like this. So what the heck is that? We're gonna find out in the next video, I believe.